The telescope was invented by a Dutch optician 4 centuries ago. Before that, it was believed the Earth was the center of everything. The theory that it actually revolved around the sun was discounted. In the hands of Italian astronomer Galileo, the telescope brought reality into focus. Modern telescopes are light years ahead of those early versions, and through their eyepieces, the universe continues to unfold. A reflecting telescope bounces and concentrates light with mirrors. Production begins with the machining of cylindrical metal parts. These are baffles, and when screwed together, they'll block stray light, which would interfere with the telescope's operation. More tools transform a solid aluminum disc into a ring with spokes. This part, called the spider, is a framework for supporting the telescope's secondary mirror. After coating the metal parts with a protective oxide, they plunge them into a vat of black dye. The dye soaks into the oxidized pores and seals the surface of the parts. Next, this molded disc of thick, low-expansion glass will become the telescope's primary mirror. A diamond-edged tool rotates on a calculated tilt to make the glass slightly concave. To improve the concave profile, a worker coats the glass with abrasive. He adds a weight to a precisely curved cast iron disc and spins it. The weighted iron disc bears down on the abrasive-coated glass to fine-tune its curvature. A worker then examines the surface for scratches. And using a calibrated gauge, he measures the radius of the disc to confirm that the concave profile is precisely what it needs to be. The glass now spins, while a cylindrical cutter aims dead center to cut out a hole. This center hole is sized to accommodate the baffles we saw earlier, and it will also enable the mirror to be held securely in the telescope. Next, the glass disc oscillates as an automated tool rubs a compound against it to polish it. A worker then applies some of the compound onto a polishing disc and works the surface of the glass against it repeatedly. This hand polishing improves the surface considerably. In the laboratory, a technician compares the primary mirror glass to a grid to verify that the dimensions are accurate. He aims a laser at the glass. A computer analyzes the reflected light. If the angle is off by 1/1000th of the width of a hair, the telescope's image could be blurry. The glass is now ready for its mirror finish. They lock it face down in a vacuum chamber. They add small amounts of titanium oxide, silicon monoxide, and aluminum. They close the chamber, tightly encasing the contents, and then pump out most of the air, creating a partial vacuum inside. They activate a 6,000-volt electrode. This sparks a glowing discharge of ions onto the now rotating glass disc. These ions blast any lingering contaminants from the glass to give it a serious cleaning. They heat the aluminum, titanium, and silicon pellets, which evaporate into a cloud of vapor. Atoms condense, landing on the surface of the glass to form a glossy mirror surface. It takes just minutes for this highly reflective coating to be applied. This telescope mirror is now ready to reflect light from the stars and planets in the sky. Next, a technician screws lenses into the metal housing for the primary mirror. He adds a mount mechanism for the eyepiece, complete with knobs for focusing. He flips over the assembly and slides that precision-made mirror onto the housing. A cork ring cushions the mirror so that a retaining ring can be installed without a scratch. The telescope's primary mirror is now secured to the housing. He pieces together the 3-part baffle, then screws it to the lens holder, protruding from the center of the telescope mirror. He joins the baffle and mirror assembly to the telescope tube. The tube has already been equipped with the secondary mirror, which will bounce reflected images from the primary mirror back for magnification and viewing. It's taken about 6 weeks to build this telescope, and now it's ready to help unravel the mysteries of the universe.